So we came here with our proposal for our project. Well, the proposal is based on security. So our security solutions are characterized by being an innovative company that will adjust to the needs and budget of our client. So the proposal for our security system, the Eagle 1.0, is a high security system that is based on equipment. This equipment is integrated by combinational logic to safeguard an asset. The system consists about access restrictions, alphanumeric passwords, alarm, and motion sensors to safeguard our client.
Today, the care and protection of your investments and personal safety are undoubtedly necessary. That is why, as a socially responsible company taking care of its clients and their pocket in this contingency, we gave ourselves the obligation to undertake with this innovative security system to take into our hands the safeguard and protection of your family, savings, company, and everything that needs a dugger. The requirements of a comprehensive and effective security system can encompass endless guidelines. That is why during the development of the Eagle 1.0 system, the following list of basic requirements was managed from a private survey. 12 numeric passwords need to be entered for access. Only 3 errors will be allowed when entering the first 2 passwords, otherwise the alarm will be triggered. Correctly entering the first 2 passwords will give you access, and consequently, a 1-minute countdown will begin. A third password will be needed to stop the countdown, otherwise the alarm will be triggered. When the 3 passwords are entered correctly, the system will continue operating to detect abnormalities in the previously configured sensors. The system must have a switch to power the equipment. The system must have a reset button for failures or accidents. While leaving the system on, the sensors have to operate in normal mode despite no residence passwords. When the alarm is activated, you must know the reason for which it was activated. When the system is turned off, the alarm, sensors, and access control stop working. The security system will be formed entirely by combinational logic.
Okay, so we are going to start with the explanation of basic engineering of the Eagle 1.0. So here we have the PCB structure. The PCB structure is only the physical part of our system. Then we have the reset of the system, that is only a push button that will reset the system. Then we have the power supply. The only function of the power supply is to energize the system. Then we have the validation inputs of the password, is where the user type the password. This validation will be linked to a counter of mistaken password. These counter of mistaken passwords will be linked to alarm design. The alarm design is also set up by an array of sensors. This array of sensors, if some of the sensors are activated, the alarm will start function. Then we have a sequence of validation password. This sequence of validation password is when the owner of the house is already in the house and he has to type this sequence of validation. This sequence of validation will be restricted by a countdown security system that is only a time lapse where the user has to type the password into the system. Okay, so we're going to start with explanation of the detailed engineering. Detailed engineering will be divided in 5 stages. Here we have the first stage. This first stage is composed only by a switch, by a push button and a switch. This push button works as the reset of the system, and this switch works as the power supply. So every time the switch is connected to the voltage, our system will start working. Then we have the stage number 2. In the stage number 2, we used two 4017 CMOS. These 4070 CMOS are the ones that work to make our passwords, or will make the validation of our password. So every time that the user type a correct password, this clock will send a pulse to our CMOS. And when the user type an incorrect password, this second clock will send a pulse to our counter of mistakes. The counter of mistake is set up in the stage number 3. This LED indicates where both of the passwords are correct. They turn on when the passwords are correctly typed. Okay, then we have the stage number 3. In the stage number 3, We have our counter of mistakes. In the counter of mistakes, we have a 74LS90 that will work as a counter. So every time that the user type a whole incorrectly password, this clock will send a pulse to our counter, and these mistakes will be displayed in this 7-segment display. When both of the passwords are correctly typed, this LED will turn on. Then we have the stage number 4. In the stage number 4, we have the design of our alarm. Apart from the alarm, we have the 74LS73. That is the one. The 74LS73 is monitoring our system. So when this LED is turned on, that is a red LED, it means that the system is working. And when the second LED, that is this one, is turned on, that is a red LED, our system is not functioning well. Then we have our alarm. Our alarm is composed by a 74LS73. So this 74LS73 receive pulse when some of the sensors are activated, or when the counter of mistakes reaches limits, and when the time of the last validation system, that is in stage 5, it will reach its limit. So when it receives a pulse, it will turn on these LEDs. These LEDs works as a policeman light, or a police light. And we have here a buzzer. This buzzer will start ringing when the alarm is activated. Okay. Finally, we have the stage number 5. In the stage number 5, we have a decay counter, a 74LS190. That will start a countdown when the user is already in the house. This countdown will be about 60 seconds. During these 60 seconds is the time for the user to introduce a new password. This password work as in the stage number 5. We use a 4070 CMOS, and when we type this password correct, our system will register that we are in the house and we are the owner of the house.
Well, as explained in the previous phase, we will observe the behavior of the system in the multi-sys simulator. It's worth mentioning that due to time lags within the simulator is something through continued time errors, what translates to time error in the simulator. This clearly in real life will not happen, that you will work for a time on par with real life. Well, in this part you know how the Eagle 1.0 system works, you know all the parts, and now you're gonna see it work. Well, in this part we're gonna digit the correct password, that is 0, 1, 2, 3 and 4, and you see that the green turn on. Well, in the other section we are gonna digit the alphabetic password, sorry. Theta G, where we're gonna fail 1, and the count goes to 1. T, the count goes to 2, and we're gonna to put the correct password, X, W, and when we put the letter B, the count is decreasing, as we tell us, it's 1 minute, and we need to put the other password to stop it. We put it, and the countdown is stopped now, and all is working. We see that the green LED is working because all the sensors are in correct form, the yellow LED is open because we put the two first passwords correct. Well, we are going to fail one digit in the password to show that this display goes to 3 and the alarm is triggered. Well, we will listen a little bit the alarm, and the lights of the police is like this in these LEDs. Well, we now listen the alarm, so we reset the alarm with the letter O. Well, this is the error that we mentioned. That is about the times of the simulation, but well, don't worry. Well, we run the simulator again. We press the letter O, and well, the simulator is in correct order. We are going to prove now the sensors. We have in the garage door, in the principal door, the windows, and in the outside door. Well, we're supposed to go from some vacations, or I don't know. Well, someone is trying to enter in the windows or in the principal door. Well, you are going to put the letter D, and you know the alarm is activated. The LEDs of the police are on. Well, you know what sensor is activated the alarm, and you know where the person is trying to enter. Well, we stop the alarm with the letter O, and well, we saw that we have these LEDs on, and we know that they are trying to enter in Windows. So well, that's the system. Thank you for all. I hope you enjoy it.
So the components to be used within the system are the following. We will have 3 acrylic keypad base, 2 switch breaker, 24 push buttons, 3 CD4017, 5 74LS32, 3 74LS08, 1 74LS04, 22 LEDs, 1 74LS90, 3 74LS47, 2 74LS190, 4 74LS73, 1 buzzer, 7 2N2222 transistors, 7 resistor of 1 kilo ohm, 7 capacitor of 10 microfarads, 9 74LS14, 1 opening motor, 4 sensor of proximity motion, 1 display of 7 segments 1 digit, 1 display of 7 segments 2 digits, 1 SI 5351, and 1 regulated source of DC of 5 volts with 4 outputs PCB.
The design of a prototype was made on PCB. It should be noted that all the components and outputs were added to the board for visual purposes. However, this can be isolated to fulfill their external function. The complete system of Eagle 1.0 was designed inside a 240 per 141 mm PCB. It was necessary to compact the system to a lesser extent than an iPad, so the installation and effectiveness of the security system meet the quality standards of our clients. Security Solution is proud to present the following prototype ready to be machined and assembled. Eagle 1.0 welcomes you to your new security system.
During this semester, I have a lot of different experiences during the course of logic automatisms. I am very proud to say that all of them come with a great learning. The design of the course and the laboratory exercise show me the magic beyond logic automatisms. Furthermore, the importance that binary logic has for my development as an engineer and for the development of automation process that as our teacher Aragon told us, the experts and the ones who are completely specialized in the automation of process are the mechatronics. So this is very important for our career, and I think the way I learned logic automatisms was very important because I learned a lot of new things. I have a lot of good and bad experiences, but these experiences always come with a great learning. So I am very satisfied with the knowledge that I received from this course and from my teacher Alejandro Aragon. So thank you for the course, teacher. Thank you for teaching us during this semester.
The learning during the project was fascinating. I bet not to be able to carry out in hardware and in the laboratories. However, the vision and line that a project of this nature takes, I'm very pleased to be able to make sense of it. I want to congratulate you because as a teacher and as a person you have created me an unequaled interest in automation and related process. And finally, as a feedback, the course seemed to me to be very complete and challenging. Thank you for all.